Hello everyone and welcome to Ocean Cadence. Today, in continuation to our series about the cooling water system, we will be undertaking the topic of heat exchangers, and the first one that would be covering is the plate type heat exchanger. As we all know that on board a ship or in most of the industries also, there are two basic types of heat exchanger designs that are used in the modern day cooling systems. That is the plate type and the shell and tube type. Now, the plate type has been developed because of its higher efficiency in terms of the fact that these heat exchangers have a lower downtime. They are much more easier to handle. They are much more easier to isolate. They are much more easier to clean, and they have a higher performance efficiency as well. So before we go on analyzing that why these functions are available or how this happens, we have to look at the basic parts of a plate type heat exchanger. In this view, you can see that the plate type heat exchanger, like any heat exchanger, will have two mediums. One is the cooling medium and one is the medium that is supposed to lose the heat. So a high temperature fluid and a low temperature fluid. In this example, we are taking it namely as seawater and fresh water, since this is a part of the HT cooling circuit. The seawater in this diagram is being shown as the inlet from the bottom side, whereas it is leaving from the top, that is the seawater outlet, and vice versa. The fresh water is arriving into the cooler from the top side as well as it is leaving from the bottom side. The serrations which are shown on the side are available for the long studs to pass that are ultimately used in tightening the plate type heat exchanger along with all the plates. So now let us look at a side exploded view of the heat exchanger. Now in this diagram you can see that the gasket arrangement of different plates is different, which we will be arriving on shortly. Now when the seawater enters the cooler from the bottom left corner, as you can see, proceeds hereafter and exits on the top left corner. In between this inlet and outlet, the seawater enters every alternate plate and acts as the cooling medium. The first plate, which is often called as the cushion or the spring plate, is used to tighten as well as provide a sealing surface on the main tightening plate or the shell plate. This first plate is the one which has no flow of fluid medium between itself and the tightening plate, because on the other side of the tightening plate there is no heating or cooling medium that is there, as well as the thickness of the plate is different, so there is no flow in between this and the first plate. So what you can see here is that the first plate will have all the four openings of itself covered with gaskets, so that there is no flow through this plate, and the corrugations will also be generally absent in this plate, or it can be there but it can be used as a side plate. The gaskets will be so that there will be no holes or openings in the gasket to allow any flow of fluid in any direction. As we move on to the next plate, that is the next one in which seawater is flowing, you can see the seawater is moving upward once it enters. The movement of the fluid is a virtue of its pressure, obviously, and what is important to know is that in case if the fluid is moving up, the corrugations will be so arranged that the corrugations will also be facing in the same direction. That means the triangular corrugation or the serration that occurs on the plate would be so arranged that it would be in the same direction. Why it is so is because it allows for the channel distribution of the liquid, that is, it separates the flow of the liquid into small channels, provides turbulence, and also provide unidirectional flow as it moves upward or vice versa downward in case of a downward facing corrugation, and by doing so it allows higher heat exchange efficiency to occur in the cooler. So the fluid will pass upward and then finally join the stream of the fluid that is exiting through the cooler, and this continues for every alternate plate until the n number of plates that are being put into the plate type heat exchanger. Similarly, For the fluid that is supposed to lose the heat, the corrugation will be arranged in such a manner on the specific plates through which the fluid flow has to occur. The corrugation will be so arranged that the direction of these corrugations will be opposite to the direction of the cooling medium corrugation plates. Why it is so is because, first of all, the direction of the flow has to be opposite. Now, why this has to be opposite? Because if we are allowing the flow of cold medium, that is the medium that is ready to absorb heat, as well as the hot medium, that is the medium that is ready to lose heat through the same entry points, that is at the same level, what will happen is that the gradient of the temperature difference at this point will be too high at the entry point, and simultaneously the heat exchange efficiency will go down. This will also mean that the heat exchanger fouling will be much higher as compared to what we observe in the alternate arrangement. So what we do is that if the cooling medium is entering at one point, then the simultaneous arrangement for the fluid that is about to lose heat will always be the exit point, and similarly at the exit point of the cooling medium, the inlet of the heat loss medium will be arranged. So it has been found that by doing so, the thermal stresses are not very high in the cooler. The gasket will obviously run for a longer period of time due to lesser expansion, due to lower temperature gradient occurring, and also less fouling of the cooler will occur. Now again coming back to the point of corrugation, because the flow is in opposite direction, so obviously the corrugation also has to face in the opposite direction for alternate plates depending upon which particular fluid, that is the cooling or the heat loss fluid, that plate is catering. So accordingly the corrugation will be arranged. Now it is important to know that these gaskets on the edge can have a point where there is a telltale hole assembly. This can either be in every gasket or alternate gasket. Mostly it is available in every gasket to easily figure out where the fluid loss or leak is happening. This telltale hole can also be there in the plate side. Usually a typical arrangement is used for freshwater generator plates, that because we know that the feed water of the freshwater plates is arranged in a certain fashion. So when you are opening or boxing back the plate of the plate type heat exchanger of freshwater generators, you will find that there is a hole underneath the gasket point on the seawater side. This seawater side is the one that is being used as the feed inlet, that is on the freshwater generator specifically I am talking about. Now coming back to the general plate type heat exchangers, again you can see that on the extreme plate there will be at the back side again one more cushion plate or buffer plate, and then finally the tightening plate. The frame plate and the tightening plate, that are the two extreme plates, the thicker ones, are the ones that are supposed to bear the load of the compression that is happening when we are tightening the nuts on the stud. So as we keep on tightening, the stud will move through all the plates on the sides and finally come out of the both the extreme plates. Then we tighten the nuts, and then by torque tightening we keep on compressing these plates and then tighten the complete heat exchanger. While the term compression of the plates is generally used when tightening the plate type heat exchanger, but what actually happens is that instead of the plate getting compressed, it is the gasket that gets compressed initially. Because if the plate is allowed to compress, then the size of the plate laterally will change, which will mean that the arrangement of the plates can get distorted. So what we do is, by using efficient gaskets, good quality gaskets and the new gaskets, what we allow is that the compression should occur mostly on the gasket surface instead of the load going onto the plates, and by doing so the gasket will seat perfectly on every plate surface and thereby provide efficient sealing and no fluid loss during the heat exchange process. It is important to know that when we are opening up a heat exchanger, the box back has to take place in an order, that is the original stack order of the plate type heat exchanger. The plates should not be intermixed under any condition, because I have already told that the corrugations are separate, the gaskets are separately arranged in different direction, as well as the telltale holes will also be arranged in the same manner. So the plates are not to be confused amongst each other. It is also important to know that excessive tightening should not occur at any point of time. As I already explained, if the plates are squeezed too much, then there can be deformation on the plates, they can squeeze out, slip out, and this can not only alter the heat exchange efficiency but can also create loss of fluid and leak of fluid in the heat exchanger medium. During the cleaning of this heat exchanger, it has to be specifically noted that the corrugations are cleaned nicely with either a cleaning aid or with water pressure, and while doing so, the gasket, if to be reused, should not be disturbed. However, most of the manufacturers, they recommend that if the cleaning is occurring at the specific interval set by the manufacturer, the gasket should be replaced completely. The nitrile rubber gaskets that are being shown in this diagram are usually present in X number on board every vessel as pairs, and if not, then they should be critically raised through the requisition so that the gaskets are always available in this pair. The plates that are being shown here are mostly of titanium grade because the tolerance limit of the plate for lateral expansion as well as the compressive forces as well as its distortion due to heat exchange should be minimal and the other tolerances should be maximum. So titanium plates are being used, and because these plates have a very long life service which is as good as the lifespan of the vessel, so the cost ratio is not very much bothersome. If the heat exchanger efficiency is to be increased as per the manufacturer's recommendation, simultaneous addition of plates can be done. However, that has to be done only in case of service letters being received by the ship that is being sent from the manufacturer. It should not be done without consultation as it can lead to loss of fluid medium as well as untoward decrease in the heat exchange efficiency as well. Decreasing the number of plates vice versa would mean that the tightening torque would also change for the plate type heat exchanger, and the same should be consulted by the manufacturer as well. I hope that this video clears all the doubts pertaining to the plate type heat exchanger, and if any doubt still persists, please feel free to drop down into the comment section and let us know your doubts, and we'll address them as soon as possible for better communication. I also request all my viewers to subscribe to our channel and share these videos with your friends and everyone in need so that we can keep creating such engaging content further. Thank you everyone.